We would like to approximate this definite integral using a Riemann sum and 5 rectangles with the right-hand rule. Let's go ahead and do that. All right, so here we are. We want to first, I always start with finding the width first. Other people may do that differently, but I like to find the width first. If I'm using 5 rectangles and we're going to go from -2 to 3, that means the width of each rectangle is 1. I'm just going to write the first subinterval, well, I'll write a few subintervals, I guess. The subintervals that we're going to be looking at, so we're going to start at -2, go up to -1, then go from -1 up to 0, 0 to 1, 1 to 2, 2 to 3. This says use the right-hand rule. As you can see, we're going to start at -1, then we're going to go up by 1, then we're going to go to 3. Therefore, the Riemann sum using 5 rectangles is going to be equal to f of -1 multiplied times 1 plus f of 0 multiplied times 1 plus f of 1 multiplied times 1 plus f of 2 multiplied times 1 plus f of 3 multiplied times 1. In this case, multiplying by 1 doesn't change anything. I could factor out a multiplication by 1. Excuse me. But that does not do anything for me. I'll write it down here, but multiplying by 1 does not change any values. Let's go ahead and calculate. Remember, the function inside here is x to the 3rd. I'm just going to leave off this multiplication by 1. F of -1 is -1 to the 3rd, which is -1. F of 0 is 0 to the 3rd, which is just 0. F of 1 is 1 to the 3rd, which is just 1. F of 2 is 2 to the 3rd, that's 8. And F of 3 is 3 to the 3rd, which is 27. Therefore, I get a Riemann sum of 35 when I add those things up. So the approximate area using a Riemann sum with 5 rectangles would be approximately 35. The obvious question looming here is, how good of an approximation is that? We saw earlier in this section that some approximations are better than others. So how good is that 35 approximation? Or how close are we to the actual signed area for x to the 3rd? Again, some of that signed area will be negative here, and some of it will be positive. By that, I mean counting towards the total signed area as negative and counting towards the total signed area as a positive.